Hello, pre-algebra students. Mr. Lawrence here with another flipped lesson, and we are going to check this out here. We are going to calculate the area of trapezoids. And remember, I'm going to use this same basic formula I've been using. The area of the trapezoid. By the way, how do you know it's a trapezoid? It only has one, it's quadrilateral with one pair of parallel sides. Okay, and I'm going to use some form of base times height. Okay, now it's a little bit of a special case, and before I actually use it, I want to point something out here. Okay, in this case, a trapezoid actually has two bases. How do I know this? Well, let's say I put this piece in here, and let me change that piece so that it looks like a broken line. Okay, you see that? And that's actually my height, right? Well, I come up with two right angles. I get a right angle here, and I get a right angle here. So I actually have two bases. Trapezoids have two bases. Did I mention that trapezoids have two bases? Now, which one do I use? Well, instead of trying to regurgitate a formula, I'm going to just say what happens if, right along that height, if I cut that triangle off. You see that triangle that's there? What if I cut him off? He's gone. Okay. And now I'm going to flip him upside down. Okay. And I'm going to take him. Oh, okay. I'm going to take him and paste him over here. What did I just create? Well, a rectangle, of course. Now, before I actually do that, I want to point something out to you. There we go. Let's put him back here. Notice that this little piece right here, this little piece is 3 centimeters. Okay. And so when I cut this triangle off, okay, and then I flip them, and I shift them over here, okay, I've just added 3 centimeters onto this side, haven't I? So now this base has become 13 centimeters. Would you agree with that? Because it was 10, and then I add the 3 on. So 13 centimeters. Okay, now remember this one was 16, but it lost the 3. So from here to here, it's also 13 centimeters. Now, check this out. If we were on a number line, we get a kind of a number line thing going on here. If we were on a number line, okay, and I'd say, 10 was here, and then 11, and 12, and 13, 14, and 15, 16, right? Let me write those numbers in there. So there's 10. Just write them smaller. And 16 is here. And if I find the number that's in the middle, I go 1, 2, 3. That would be this number here. Isn't that 13? I mean, I go 1, 2, 3, right? And then 1, 2, 3. Gone 3 spaces on each side. 13 smack dab in the middle. Well, this was a lot of work to find out how long the base needs to be. But finding another in the middle of two numbers is also the same as finding the mean. Or you could argue that it's also the median in this case. And either one is fine. But to find a mean, we add the two things, 16 plus 10, and then divide by 2. I get 26, divide by 2, and look at that, I get 13, which is the same number we said here. So we're actually going to adjust our formula here. Knowing that trapezoids have two bases, we're going to add the two bases together. And then we're going to cut them in half, because that's how you average the bases. And then we're going to multiply by the height. So this is how we're going to average the bases, right? We're going to average the bases. Well, in this problem, the original one, the first base was 16, right? So we're going to take 16 plus the 10, divide by 2. We already know that's going to be 13. And then we need the height. Now, I don't believe I ever gave you the height of this trapezoid. So let's say it's 12 centimeters. Okay? And so we're going to multiply by the 12. And so we're going to get 13 times 12. Now, if I triple 13, I get 39. And if I double that, I get 78. And if I double that, I get 156. So that's going to equal 156 centimeters squared. And there you go. There you go. All right. So to find the area of a trapezoid, we average the bases, right? So if I had a trapezoid that looked like this, say, this is called a right trapezoid. Okay. And we knew the measurements were, say, 8 meters, and we'll make this, I don't know, 18 meters. Get our right angles here, and that's 18, maybe that's 15 meters. Then to find the area of this trapezoid, okay, we're going to average the bases. 8 plus 18, divide by 2, and we're going to multiply that by 15. So 8 plus 18 is 26, divide by 2 is 13, and then we have to do 13 times 15, and I'm thinking of a cool way to do this one. If I do 13 times 10, I get 130, and then 13 times 5 is 65, so I'm thinking the answer is going to be 195. I'll leave you to verify that for me, meters squared. So, remember, to find the area of a square, we do base times height. To the area of a rectangle, what do we do? Base times height. To do the area of a parallelogram, right? It's still base times height, remembering that we need a right angle. The square and the rectangle give us right angles, but the parallelogram doesn't. We have to find the right angle, find the height, and then the area of a rhombus, which is like a tired square, right? Okay, is base times height. Okay, and then we learned about the area of a triangle, and that was the base times the height, but we cut it in half because a triangle is half a rectangle or half a square. And then for a trapezoid, whether it's a right trapezoid like this one, or it could be a trapezoid like this, maybe an isosceles trapezoid. Okay, I'm going to redraw that right trapezoid. I don't like the way it looks. Okay. All right. And we're going to average the bases because they have two. So you could argue that rectangles and squares have two bases, but the two bases are the same length, so it doesn't matter. In a trapezoid, we average the bases. Now, I don't know about you, but I look at these formulas and they all look pretty much the same. These four are identical, right? So 1, 2, 3, 4. Those are identical. And these are just alterations of it, right? And of course, those two are exactly the same because it depends what kind of trapezoid, but they're the same formula. So we have 1, 2, 3, 4, 5, 6 different shapes. I mean, you could count 7 for a different type of trapezoid, but I'm saying all triangles, this formula works. all trapezoids, this formula works. So we have 6 different shapes that use the one formula base times height, okay, or some slight variation of that. I don't know about you, but I think that is way easier to remember than trying to remember 6 or 7 different formulas for all these situations. All right, that's your lesson for today. You'll be getting some practice with this stuff. Mr. Lawrence signing off. Good night, everybody.